Hi, my name is Morgan, and today I'm going to go over the different tests that you can use to see if a series of the sequence AN converges or diverges. And there are so many tests that I have a lot of trouble keeping all of them straight. So I'm making this video to help you keep them straight and to find out most quickly which test you should use to prove if this series diverges or converges. So there's two big steps. Step number one, and this is the most critical step of all, and it's often skipped and it can save you such a lot of time, which is that the very first thing you want to do when you're given a series is you want to ask if the limit as n goes to infinity of a of n equals 0. If it doesn't equal 0, the series converges. And you're done. You don't have to do anything else. However, if a of n, the limit as n goes to infinity of a of n equals 0, it might converge. And so then, we're going to have to go and look at all the rest of these different types of tests and choose one of all the rest of these tests to see if this does converge. And so the trick about this is choosing which of these series is the right one given what your a of n is. So I'm going to start off with the p series. P series is one of my favorites because given the sequence of 1 over np, where that's your an, that's the sequence, and then you're just going to take the series of that. If you're given something that looks anything like this, where you have a variable raised to a power, you are going to want to use a p. You're going to want to use a p series because that has a very straightforward convergence or divergence. So if you see this and you recognize anything that fits into this kind of pattern, it could be like 1 over n to the 3 halves or anything like that. What you want to do is look at that p-value and see if the p is greater than 1, it converges. And if the p is less than or equal to 1, it's divergent. So that's the p-series, and it's a very straightforward test and pretty easy. Just look right at the series, don't have to do much algebraic work at all, and say, yes, it converges, or no, it diverges. So that's the p-series. Then, the geometric series is something like this. You're going to want to take the series of the sequence of a constant, or of some number, raised to a variable. It's going to look something like that. And geometric series often fit along something that looks similar to this, where there's an a, which is a constant, and an r, which we are going to raise to n. And so you're going to be able to take out this constant, and that will be a, and sometimes that will just be 1. Maybe you'll just have the other number r, and that r raised to the n is what is going to be able to tell you whether this is convergent or divergent. Because if r is less than 1, it converges, and if r is greater than or equal to 1, it diverges. So this is the opposite of the p-series when you're looking at p. And another great thing about using the geometric series is that if it does converge and r is less than 1, r is that one right there, which is